Hello everyone, my name is Asif Mujava. I'm a solutions architect here in the UK with AWS. Today I'm going to talk about deploying and monitoring SQL Server high availability workloads on AWS with Amazon EC2. So let's just get started. So SQL Server on AWS really comes into two flavors for you guys. It's Amazon RDS for SQL Server, which is our managed service with single click high availability, and it's a fully managed service with license included instances. Whereas SQL Server on Amazon EC2 is a self-managed VM by the customers. And it requires the manual high availability in terms of if you want to achieve the high availability or a DR setup, then it will have to be created manually by you guys. And at the same time, in terms of licenses, it can come with the two flavors. You can have the license included instances, or you can have bring your own instances running on EC2. So let's just dive into what this RDS and EC2's the key differences. So Amazon RDS for SQL Server starts with scaling, high availability, backups, patching, maintenance, always patching. All of these are baked in, and all this undifferentiated heavy lifting is what we call it in Amazon is done for you by default. So you bring your data and you dump it on RDS for SQL Server, and then we will do the rest for you. And all you will be doing is focusing on those business value tasks. You're doing high-level tuning, schema optimization. Even if you don't have the in-house database expert, that's fine, because then we're doing that database admin task for you, if you see what I mean. And then if you look at the right-hand side, SQL Server on Amazon EC2, what it is basically you would be responsible as a customer for scaling, high availability, backups, patching, and maintaining that database infrastructure in a way, apart from the OS install and maintenance and underlying the hypervisor level on the network level, which is what we will provide you as a basic. So what EC2 gives you that full control over DB instance, and then you will have to manage everything else on your own. Whereas RDS, on the other hand, gives you that managed service experience where you don't have to worry about that heavy lifting, admin, patching, scaling, all of that. That's already been thought through for you. All you have to do is bring your data and scale as you need it. So let's just dive into, for today's topic, that is SQL Server HA and a DR on Amazon EC2. So when we talk about high availability, really talk about I need to have my data available for as quickly as possible and round the clock. And at the same time, if the disaster hits, then I have to have a recovery plan in place. So typically in a SQL Server environment, what SQL Server offers you is failover cluster instances, which is instance level of protection. And when it comes to the other option, which is always on availability groups, which is a database level protection, and the mirroring, which is again another database level protection, and lock shipping is another database level protection. So let's just dive into what I mean by instance level protection and database level protections. So instance level protection is basically FCI, in other words, that is failover cluster instances, that covers you for any OS level or SQL Server failures. So anything goes wrong with the OS or SQL Server, you have an automatic failure with the failover cluster instances. But that your RTO, recovery time objective, could be from a second to minutes. This is a typical high HA solution. What most of the customers do on premises nowadays, when they within the local DC or in Amazon's world, will be within region. And then when it comes to scale out, you can't do the read scale out, which you would be able to do with the availability groups. That is not available with FCIs. So in terms of availability groups, which was introduced with SQL Server in 2012, and it has gone better as the versions of SQL Server has gone like in 2019. There's quite a few things we can do in availability groups. So just let's understand what availability groups are. So in terms of availability groups, what it gives you database level protection. Like in an FCI, it's an instance level. If something goes wrong with the database level, though the instance is live, you can simply just flip it over to the other side as you to your DR partner. You could have a seconds RTO with this setup, zero data loss, and effectively zero downtime for your plant maintenance, and it gives you horizontal read scaling. You could scale horizontally for your read replicas, and then you can failover to second region for the DR if you like. So let's just dive into more about how the multi-AZ failover cluster instances looks like. So this is a typical architecture for your failover cluster instances, where you have an EC2 primary instance sitting on AZ1, and you have secondary instance sitting in AZ2. This is all within a single AWS region, and you will have the witness file share sitting on AZ3, and you will have the FSX, which is the file share service for Windows workloads. That's where we will be deploying your database files, your MDFs, LDFs, and your tempDB and backups and on so on and so forth. If your primary instance goes down for OS or SQL Server instance level reasons, then your instance fails out to the secondary node in AZ2, and it starts serving your customers from there. But that's as long as your connectivity is there. Brilliant. So moving into next scenario, which is multi-AZ always-on availability groups. So what we have here, we still have that cluster solution, the WSFC, the Windows Server failover cluster, that is still there. But what we have taken out the instance level failures out of the equation here. We're literally managing everything at the database level. So anything goes wrong with the database, we have a failover, and that's what majority of the people are looking for currently in terms of their DR or in terms of their high availability strategies, where you have a primary replica which is sitting in AZ1, and you have a secondary replica sitting in AZ2, and we have the failover witness file share sitting in AZ3. This is again a single region setup where everything is set up within that region. But let's just go and look at what's more typical on-premises solutions are, where you have a DC and you have another DC. So in other words, we have a region, which is where your primary replica is deployed with a synchronous commit, where primary replica on AZ1 and your second replica in AZ2, and they are tightly coupled with synchronous replication with automatic failover. If anything goes wrong on AZ1 in region A, you will have automatic failover, and within a second you will be up and running on AZ2. Because within AGs we have the listener name, that's where your application will be connecting to. There will be hardly any difference, or your application would hardly ever notice that you're now running in AZ2. But when it comes to the typical scenario where why would we have region B, is basically if you have contractual stipulated commitment to your customers, where you state that in a contract that we will have our primary site and secondary site separated geographically in different regions. That's when this scenario comes in, where you have so let's just say I've got my primary running in the UK, and you want your secondary to run somewhere in the Europe, say Frankfurt or some Germany. So that's how you separate them out. So what will happen in this scenario, you'll have region A. Within region A, you'll have synchronous commit and automatic failover. But when it comes to region B, which is your remote DR replica, you have asynchronous commit and manual failover. So what this scenario gives you, that scenario gives you a quick failover within a region itself. That's so you have your head check covered. And if you need to invoke a DR for XYZ reason, for your own BCP planning and all that, that's where you can do manual failover and asynchronous commit, and which can bring in some data loss. But as long as you can keep your replicas in sync, there's hardly anything. So moving on to in a multi-region distributed availability groups, this is a challenge came out because of the previous example we just touched upon, that where the customers like, oh, I need to extend my AD into the other region. I need to extend my WSFC, which is failover cluster, into the other region, and it comes with its own challenges. So Microsoft just came up with, okay, with 2017 onwards, or 2016, sorry, apologies, onwards, we will have the availability groups. Well, you can have two separate clusters two separate Windows clusters running on their own, two separate ADs running on their own, so you don't have to extend anything, and then they can still replicate the data between the AGs. And this is the beauty of the distributed availability groups. But what we'll have region A with AZ1, which is where the primary replicas are, and within AZ2 you have your second replica, which is where your synchronous committees and automatic failover is available for you. But what happens on region B, you have AZ1 within region B, which is a primary replica. It's not really a primary replica, it's a forwarded instance. So the data is pushed from region A AZ1 to region B AZ1, and then the primary replica or the forward replica within AZ1 in region B becomes the forwarder to AZ2 replica within region B. So there is no data getting replicated from AZ1 region A to AZ2 region B. That saves you your network charges there. And then again, it's just far more efficient to push the data out. So that's another thing. So today, what we're going to cover the demo for our multi-region AlwaysOn availability group with the replica synchronous committing in A region and an asynchronous in other region. So let's just go over it. So what are the prerequisites before we start to build? We need AWS managed directory. We need service accounts with the domain privileges. We need your VPCs between primary and second region connected with the either VPC peering or transit gateway. And Active Directory domain controllers should have all the posts open to our security groups for all SQL Server nodes and domain. So let's just go get started. So what we're going to do, we're going to go type in our console SQL Server, and that should present an option. So we're going to pick up SQL Server 2019 with SQL 2017. I'm just going to select that, and I'm just going to go give me all my memory optimized instances. So I'm going to go R580 large for the demo. I'm going to use that. Configure instance details. I'm going to pick up my CIDR block. That's the CIDR one I'll do. And I dump my SQL instance into a private subnet. And I'm going to go next. I'm going to add storage because I need to store my data. I need to store my data. I need to store my logs. I need to store my temp and backup. So I'm going to go add next tags, and I'm going to add name SQL HA demo. That's what I added. Configure security group. So I already have security group here. I've got admin management and MS SQL Server. So I'm just going to go MS SQL Server, which just allows the traffic for 1433 and some peering connections, which I already have baked in. And then Bastion host to connect for my management RDP 2389. We're just going to go review and launch, and that's it. So while I've done that, so in the background, I've already deployed my instances here for you. So we got SQL HADMO A and a B in the Frankfurt region, and we got SQL HADMO C in the Ireland regions. And we have the these two instances talking via the VPC peering of transit gateway apologies, and that's already been set up for them. And then we have security groups set up. In a security group, I'm allowing the traffic coming from my Bastion host on a TCP and an RDP post, and then this is my CIDR block for my Frankfurt region. That's allowing all traffic. And then if I go into my Frankfurt region, I'm going into my security groups. I'm doing the same thing. My Bastion host security group is allowing TCP and RDP, and then I'm allowing my Ireland region to come on all paths. So here we go. So that's the instances up and running. I'm literally quickly gonna go into my Bastion host. I'm logged in here already. So I've created a cluster called SQL HADMO CLS, SQLHADMO.com. That's basically by running the create cluster, or I can simply fire up the clusters, and then if I go, but first thing I need to do is make sure Windows firewalls are modified to allow port 5022 for always replication, 1433 and SMB on a firewall to be allowed to do that. Or else you can turn it off as long as you have protection covered on the under your infosec policies. And then what you do, then you install the failover clustering features by going to the server manager, and then you go into the manage, add roles. Once it gets ready, add roles, go next, 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 and then you go failover clustering. And that's you install it. Once that's installed on all the nodes which are participating in our scenario, we have for 2 nodes in Frankfurt, 1 node in Ireland, and all of them are joined in. Once this cluster is created, what I did then, I went in and enabled the SQL Server always on feature on the SQL instance itself. So I went into the SQL services, and I went into Microsoft SQL Server service. I went into always on availability and clicked on enable always on. And that's it. And then that way it was enabled. At the same time, what I did, I switched my services on this my service account on the services to run SQL HDMO SQL admin, which was created for me, part of the prerequisite I've done. So what I did then, I went into creating my always on security groups. I created a database called a SQL HDMO. I ran the script which created my always on my availability group with the primary replicas and the secondary replicas and a listener, which is what we said when we create the instances here in EC2. What you do, you add 3 IPs. So you go to manage IPs, and then you just go into there and then say add new IP addresses. So I've added already 2 IPs apart from the 1 IP which came by default when I spun up the instances. So that gives me 1 per cluster and 1 from my availability group listener. Right, so let's go back into our setup. So my age is created, my data started flowing. So what I do, if I wanted to monitor this, so how do I do it? So let's just come back. So in terms of monitoring, as you see how I built it. So in terms of monitoring SQL Server HA in a CloudWatch, there are 2 options. It comes with the default monitoring, which is what you get in the CloudWatch, or you can do an enhanced application insight monitoring. So I'm just going to walk you those 2 options now. So the default monitoring, which you get with the SQL Server, if you are with the EC2 instance, if you go to your instance, go to monitoring, you will see all your CPU, your network, your disk related stuff in here, but that doesn't dive into your SQL Server stats, if I may. And same thing will happen on the other side as well. So we can just go to make sure the other side looks same, monitoring, we got CPU, network in and out, and that's about it. But it's not diving into in terms of SQL Server stats. So what I do, normally I go in here, and then what you can do, you can look at the dashboard, show the dashboard for your availability stats, and then that could confirm what you have deployed. My primary instance, which is in a synchronous commit with automatic failover, my secondary instance in a synchronous commit with automatic failover, and my third instance in a different region is asynchronous commit but manual failover, but CT mode is automatic. And then you can see here a replica name, and what's the state of replica and failover readiness. Does it have any data loss or no, or nothing? So my 2 replicas in Frankfurt has no data loss because they are running in synchronous commit mode with automatic, whereas my 3rd replica in a different region in Ireland has got synchronizing and has got data loss because it's doing async replication. So let's just look at in terms of monitoring. So we just covered the basic monitoring. In terms of the deep monitoring or the enhanced application monitoring, so CloudWatch just released a new feature called application monitoring. So what you do, you go into the CloudWatch from your console, you go to the settings within CloudWatch, and then you go to application insight. That gives you you can do the configure metrics, the custom metrics, logs and alarms for your application for .NET, SQL Server, or MySQL. So go into the Viva application and go into add application, you create a resource group, and basically what that does, that's just goes and creates what all the instances you want to create for. So I just say, hey, I want to do my EC2 instances, and I just go, my name and my tag is SQL HDMO, for example, and I do and name the SQL HDMO, and I hit create group. I already have a group created here, and this is my Frankfurt side, which is where I have a Bastion host. which carries that tag. Then I've got two SQL nodes, which is SQL HTML A and SQL HTML B. Once that's done, I can then come back and come to my CloudWatch and into my application side, and then you should have that application resource group listed here, and then you just click on add application. Once that application is created, my SQL HTML is already created for me here. All I have to do is go in, apologies, I'm on the other side, and let me just change that to Frankfurt. If I go into Frankfurt, then I can see all my 3 instances being listed here already for me. By default, this will not be enabled. So all you have to do, you have to go in and click Manage Monitoring and click Enable Monitoring. And then within the application tier, select Microsoft SQL Server Database tier. And then if you keep scrolling down, this is where you will have to choose your custom metrics, what metrics you want to catch. So there are quite a lot of them. I wouldn't necessarily dive into each of them, but for this demo, I picked up all the replica related. So whatever AlwaysOn is replicating, all those metrics are picked up and I saved it. And that way, the metrics have been collected. So if I go to my metrics, and then I go to all metrics, and I click on CW agent, and then I go to instance ID, and that's my instance ID, and I can select my metric names, and then I can pick up which one I want to plot. So here I am plotting SQL HTML for replica logs and queue and replica transaction delay. As you can see here, I'm running some queries in the background, which is generating a traffic. So at the moment, there is a transaction delay of 525 millisecond, but the logs and queue is literally 0. It hasn't gone beyond that. And then if I go back to, apologies, I'm just going to go back to my previous graph, which I had here, which I can just simply go in here, CW agent, and then go in here. And what I'm going to plot is basically replica log bytes received a second. Let's just do that. Okay, so you can see the second instance on the island side has been receiving the log bytes, and that's the plot. That's the graph here. And then again, within graph option, you can go 5 minutes to a second. I can go a second, and then it just gives me more granular level detail. And that's about it, chats for today. I hope you enjoyed it, and I hope you liked the talk, and hopefully I'll speak to you guys later. Thank you.